Hey math kids, today we're going to talk about differentiability and continuity. So it says if f is differentiable at x equals a, then f is also continuous. So if there's a derivative there, then it's continuous. If a function is not continuous at x equals a, then it is not differentiable. Okay. So let's just jump in with an example. So let's look at the absolute value function, but let's look at it as a piecewise function. Like that. So it says prove that it is continuous but not differentiable at x equals 0. So continuous but not differentiable. Okay. So if we look at the limit as x approaches 0 from the negative side of f of x, we see that's the same thing as the limit as x approaches 0 from the negative side of negative x. And basically, if we just plug in 0 to that, we get a 0. Okay, the limit as x approaches 0 from the positive side, limit as x approaches 0 from the positive side of f of x, same as this. We plug in it in x, we get 0, and then that tells us that the limit as x approaches 0 of f of x is equal to 0, which is equal to f of 0. Okay, so therefore, because remember, for the limit to exist, both sides have to be the same. Both limit from the left and limit from the right have to be the same. And then if the limit is equal to the y value, then we know that it's continuous. So we know it's continuous at x equals 0. Now, if we take the derivative, so we have to take the derivative of x and the derivative of negative x. So the derivative of x is going to be the limit as x approaches 0, or h approaches 0, of x plus h minus x over h. So x minus, if we just simplify that, these cancel, h over h equals 1, and the limit as x approaches 0 of 1 is still 1, and so the derivative is 1, like that. And then if we do the same thing, limit as h approaches 0 of negative x plus h minus negative x. Distribute that negative. Negative x, negative h plus x over h. These cancel each other. Negative h over h is going to give us negative 1. Limit as h approaches 0 of negative 1 is negative 1. Okay, so that's what our derivative function looks like. And if we look at f prime negative of 0, it's negative 1. If we look at f prime positive of 0, it's equal to 1. Since those derivatives are different, it is not differentiable. So, just to recap, for absolute value function that looks like this, it is continuous, but it is not differentiable. So at this point, x equals 0. It is continuous. There's no break, jump, removable discontinuity, none of that. But it is not differentiable because the left derivative and the right derivative are not the same at 0. Okay. If you have additional